In this video, we're going to look at an overview of the selection sort algorithm. The strategy of the selection sort algorithm is to find the smallest value in the segment remaining to be sorted and then position that value as the first element in the segment. So we've taken a sample array here, and what we're going to do is step through the sorting process. So at the beginning, we start at the first element in the array, which is F0. And what we do is we kind of then look at the rest of the elements in the array. So I'll signify that with a green line. So this is I plus 1, and the yellow line is I. So you can see I starts at 0 at the beginning, and then what we're going to do is we're going to look at the rest of the array. So we'll go through the rest of the array and see, is there an element in the rest of the array that is smaller than 5? Essentially, we're trying to find what is the smallest element in the portion of the array from the green line to the end of the array. So we look through here and we see, well, 4 is smaller than 5, but 2 is smaller than 5, so that's the smallest so far. Then 12, that's bigger, 7, that's bigger, 10, that's bigger, and so on and so on. So 2 is the smallest value out of the rest of the array here. So let's circle that in red. So that's the value. Now what index does that occur at? Well, that occurs at index 2. Happens to be the same value, just coincidental. Let's call that index k. So what we do now is we say, okay, we've got 5 at the start here, but the smallest value out of the entire array is 2. So we should really move positions. We should swap 2 with 5, and that's exactly what we do. So we take the value 2 and we move it into that position, and we take the value 5 and we move it into the position that k is at. So if we rewrite the contents of the array out, we'll have 2 now at the beginning, 4, 5 got switched with 2, and then we have 12, 7, the rest of the values in the array stay the same, 6, 13, 8, and 15. Okay, so what happens next? Well, we've done the swap at the beginning and we're now sure that 2 is the smallest value. So effectively the array is kind of sorted for the first element. So we move on through the array and we say, okay, increment I. I is now here, and I plus 1 is here. And k, well, we reset k back to I. So for the moment, k is kind of, well, let's do it in red. For the moment, k is here. But it will change in a minute. Or it will change as we process the array. Okay, so we look and we have a 4 here. And we go through the rest of the array as we did before and see, is there an element or a value that's smaller than 4. So we've got 5, that's not smaller, 12, no, 7, 10, 6, 13, 8, 15. Okay, so there's no other value that's smaller than 4. So effectively 4 is already in the right position. So we don't have to do anything, we can just move on. So if we rewrite our values back down into this empty array, we have 2, 4, 5, 12, because nothing happened in the previous loop, no change. 4 was in the correct position, 13, 8, and 15. Okay, so where is I now? Well, I has incremented on one more position, so now it's here. And I plus 1, of course, is one step further on. So the green line, I plus 1. And k, Well, k did nothing the previous time round and it's just tagging along with I. So let's have a look now. We've got 5 and we're going to search the rest of the array and find the smallest value in the rest of the array. So we've got a 12, that's not smaller than 5. 7, that's not smaller. 10, 6, 13, 8, 15. Okay, there's no other value smaller than 5, so once again we don't have anything to do, we can just move on. So we can increment I and move on. So here we have I, and we've got I plus 1, and k has tagged along with I there. Alright, so now we have 12, and we search the rest of the array from the green line onwards to see is there a value smaller than 12. So we have 7, okay, that's smaller than 12, but we don't just stop there, we find the smallest value out of the remaining values. So we have 10, 6, okay, that's smaller again than 7, so that's okay. So now it looks like 6 is the smallest value so far. 13, 8, and 15. Okay, so 6 is the smallest value, so let's circle 6. And now what we say is, okay, set k equal to wherever 6 is. Alright, so now k changes. K now gets set to here and has an index value of 6. And what we do is we carry out a swap. So we had 12 here where I was, so we're going to swap the value at I with the value at k. So let's do that swap. So 12 moves from here, so 12 is now gone, and we're going to swap that with 6. So 6 goes in here, 12 goes in there, and we carry on. So where is I and I plus 1 now? Well, I has moved on, we're now here, and I plus 1 is here. And we begin processing again, so we have 7. And we look at the rest of the array and see is there a value smaller than 7. So we have 10, 12, 13, 8, 15. So there's no value smaller than 7. So we don't have anything to do. We just simply continue when we process again. So that's a matter of incrementing I and continuing on. So I is now here. I plus 1 is here. And k, of course, has tagged along with I as well. So we have k there. Alright, so now we've got 10 and we have to process the rest of the array from the green line onwards and see is there a value smaller than 10. So we have 12, that's not smaller, 13, that's not smaller, 8 is smaller, 15 is not smaller. So it looks like 8 now is a candidate to swap. So we set k equal to its index, which happens to be 8 as well. So k now goes over here. We know that its index is 8. And the value that we're swapping is 8 also. So now we carry out the swap. So the value 8 now goes in where fi is, and the value at fi now goes in at fk. So let's swap those around. So 10 goes out of here, the 8 goes out of there. So we have 8 and 10 goes in there. And that's it. We can now continue on and increment I. So hopefully you're beginning to spot the steps here. So now I is here, I plus 1 is here, and k again is tagged along with I. So now we've got 12, and we process the rest of the array from the green line onwards. So we see 13, okay, that's not smaller than 12, 10 is smaller than 12, and we have 15. So the smallest out of the remaining elements that we need to process is 10. So we now set k equal to the index that the number 10 is at. So k is now here, and that's at index 8, and we're ready to do another swap. So the value 10 goes in at fi, and the value that was at fi goes in to fk. So let's carry out the swap. 12 and 10 get swapped. So 10 goes in there, 12 goes in there, and we increment I. So I is now here, I plus 1 is here, and of course k as tagged along with I again. So we have 13, and now we're going to look for a number that's less than 13 in the rest of the elements that are in the array. So we have 12, okay, that's less than 13, and 15, that's not less than 13. So the only one that we can swap here is 12, that's less than 13, and that happens at index 8. So k is now set to that index. K is now here, and we carry out our swap. So the value 12 goes in where fi is, and fi, the value at fi, gets swapped with fk. So let's carry out that swap. 13 goes out of there, and 12 goes into the first position in that segment. So 12 goes in there, 13 goes in there, and we increment I. So I is now here, I plus 1 is here, and we do the same steps again. So we have 13, oh, let's not forget k, just for completeness sake. So k tags along with I, k is here. So we have 13 and we have 15. So there's only one element left, which is 15. That is not smaller than 13. There's nothing to be done. The array is now actually sorted. So nothing happens in this last comparison here, and we just increment I. And of course when we do that, we just have nothing left to do really, because the array is actually already sorted and the algorithm will end, and we're left with a sorted array. So we have 2, 4, 5, 6, 7, 8, 10, 12, 13 and 15. So let's move over to our code window here, and what we have is a little template for our selection sort algorithm. I've already filled out some of the more basic components of this. So we have a class called selection sort. It's got a main method. I have declared the array that we've just been working with over in our little demonstration window here, and I've actually declared the same array with the same values, and I've called that array f. And what I've done is I've actually included already a method just to print the array. We've already seen methods to print arrays, so I've just declared that at the top here. I've got public static void print array, and that takes an array argument a and just as a simple for loop just to print out the contents of the array. So I declare the array and then I print the array out. So we print the array before it's sorted. So if we just compile and run this, you'll see we just get some output with the unsorted array. Okay, so the next thing we need to do is sort the array, and then we'll print the sorted array out. So rather than write all the code for the sorting algorithm into my main method, I'm going to declare another method to sort the array. So right underneath my print array method, I'm going to say public void sort array, and it's also going to take an array as an argument. So I'm going to say int, use my square brackets for an array, and I'm also going to call this argument a. So when I refer to the array that I'm sorting inside this method, I must refer to the array name a. Even though it's called f in my main method, I'm going to pass that into this sort array and I'll refer to it as a. So the first thing that I need to do in my sort method is I need a loop. Let's say we'll say outer loop to control entire sort process, and that's basically what our outer loop does. So this outer loop is going to be for int I equal to 0. I is going to be less than a dot length, the length of the array that gets passed in, and it's just going to be I++. So it's a basic template for a loop for the outer loop of the sorting process. Now once I write that outer loop, the next thing that I'm going to do is declare a little inner variable or a temporary variable k. I'm going to set k equal to I at the beginning, because remember over here k is used just as a temporary variable to store the index if we find a smaller element. So we use k just to kind of store that index so we can do the swap, and k just follows I along through the entire algorithm, and then we use it when we find a value that's smaller than fi. So every time around the outer loop we'll just reset k to I, and then we'll use it for the index of the smallest element. So the next thing that I need to do is I'm just going to write some comments in to kind of as a placeholder. We need to find the index of the smallest element in unsorted segment, and we'll use k to do that. After that, once that's done, then I know that k will equal the index of the smallest element in fi to f length minus 1. So k will equal the index of the smallest element in the remaining part of the array that we've got left to process. And if k is equal to that index, then what we want to do is we want to swap, and we're going to swap fk with fi. Now to do that we'll need a temporary variable, so I'll introduce int temp, and then I'll say temp will equal fi, and then we'll say fi is going to equal fk. So this is just a simple swap operation that we're carrying out here, and then fk will equal fi. Now fi is already changed, so that's why I stored its original value in temp. So now we'll say fk is equal to temp. And that's pretty much it. All we've got left to do now is develop this inner loop. And the inner loop is the one that's basically going to mimic this process of searching from this green line. So at the green line, the inner loop loops all along the rest of the elements that are unsorted and tries to find an element that's smaller than the current one that we're on, which is Fi. So this inner loop is the green bit here, searching or looking from the green line onwards to find the smaller element. And if we find it, of course, what we're going to do, in this case it was a 2, so we found 2 and 2 is smaller than 5, and we set k equal to its index, and then the loop finishes. We now know that k is the smallest index of the smallest value in the rest of the loop, and we can carry out our swap. So that's what the inner loop does. It just simply finds the index of the smallest element. When it finishes, then we know that that's stored in k, and we can carry out the swap. So to write the inner loop back over in our code window, what we're going to do is we're going to say for int j. I'm using j because I've just used I in the outer loop. And I'm going to say j is going to be equal to not 0, but I plus 1. Because look at our green line here. The green line is where we're processing from. So it's not at the same position as I. We've always stepped this one step forward. It's I plus 1 all the time. And down here it was one step ahead at I plus 1, and we searched the rest of that part of the array for the smallest and set k if we needed to, and so on. So in this case over here, j is always going to start one step ahead of I, and that's what the I plus 1 is here for. So we set j, and of course j is going to loop around, and it's still going to be looping around while j is less than a dot length, so that's the length of the array, and we'll just increment j. Now in this inner loop, what we need to do is a comparison. We need to find that smaller or smallest value in the remaining segment, and we'll use an if statement to do that. So we'll say if fj is smaller than the current fk, then what we need to do is we need to set k equal to j, because we found a value fj that's smaller than the current fk, and we should really set the index k equal to that index j where we found that smaller value. So this just keeps k equal to the index of the smallest all the time as this inner loop is processing. Now we don't have to do anything else, but I will put in an else just to show that that's the only situation that we need to worry about and nothing else needs to happen. So now that this inner loop has been finished, that is basically the selection sort. So if everything works, we should be able to call this on our array to see does it indeed sort the array. So let's save our code and let's compile it and see is the algorithm working or compiling. Okay, so we've got some problems here. Let's have a look and see. Yes, okay, remember what I said at the beginning? We're passing our array in here through an argument a. So when I'm in this method, in this sort array method, I must refer to the array as a. And look what I've done. I've made the classic mistake in here of saying f. So I just need to change that to a, because the array is called a in this method. So let's save and let's look down here, and I've done exactly the same thing down here with the temp. It's not f in this method, it's a. So I'll change that to a, and we should be good. So let's compile. Everything looks okay. I've referred to my array as a inside the method here, and what we'll do now is we'll call the sort. So back down in the main method, we just say sort array, and of course the array down here is called f, the actual array that I want to sort. So I'm going to pass f over to the sort array like that, and then hopefully when it sorts it, what I'd like to do is just verify that it's sorted. So I'm going to print the array out again. So I'm going to copy, let's copy these 2 lines of code down, and we'll put them there and say, okay, this should be the sorted array, and we'll print the array out again. So let's save that and compile. Oops, we have another error here somewhere. So we have a non-static method sort array. Okay. So let's go up, and as you can see, we have public void sort array. So actually that should be public static void sort array, and that will fix that error. So let's compile and run. And as you can see, we have the unsorted array 5, 4, 2, 12, 7, 10, 6, 13, 8, 15. And now we have our sorted array 2, 4, 5, 6, 7, 8, 10, 12, 13, 15. And indeed it is sorted. So that is just a very quick overview of the selection sort algorithm.